आज का जो मेरा टॉपिक है वो इंजाइम्स के बारे में है। इंजाइम्स द बायोलॉजिकल कैटलिस्ट, एनर्जी ऑफ एक्टिवेशन। If you mix 2 moles of hydrogen gas H2 with 1 mole of oxygen gas, nothing happens. अगर आप 2 मोल्स ऑक्सीजन गैस के और 2 मोल हाइड्रोजन गैस के और 1 मोल जो है ऑक्सीजन गैस का आप मिलाते हैं तो कुछ भी नहीं होता। इफ यू एड ए स्पार्क टू द कंटेनर द फॉलोइंग रिएक्शन अकर। अगर वो कंटेनर जिसके अंदर ऑक्सीजन और हाइड्रोजन मौजूद है उसको आप आग लगा देते हैं, स्पार्क कर देते हैं, तो वहां पे ये रिएक्शन होता है। 2H2 plus O2 gives us 2H2O plus del C is equal to negative 58 kilocalorie per mole. In order for water to be produced, H2 must become 2H and the O2 must become 2O, as this frees up the electrons tied up in covalent bonds to form chemical bonds forming water H2O. Energy of activation. The energy used to break the bonds in the reactants so they can be reformed in the products is called the energy of activation. Enzymes. Enzymes are biological catalysts that increase the reaction rate of biochemical reactions. Characteristics of enzymes: made of proteins or RNA. Number 2, they are very specific and only work with a certain set of reactants or substrates that fit on their active site. Induced Fit Model. Enzymes can be used over and over again. When an enzyme binds with the substrate interacts with the enzyme, causing its to change shape. This change in shape facilitates the chemical reactions to occur. This is called the induced fit model. Enzyme example: ribonuclease. Ribonuclease decomposes RNA and the nucleotides can be recycled. The purple parts is the enzyme, the green part is the substrate RNA. Enzymes work by lowering the energy of activation. Enzymes increase the reaction rate by lowering the energy of activation. They do not change, gives free energy or del C. On y-axis gives free energy, increases from bottom to top, and progress of reaction is from left to right on x-axis. Reactants convert into product. Activation energy with enzyme, activation energy without enzyme. The enzyme saccharose decomposing saccharose. The enzyme saccharase decomposing saccharose. Number 1, substrate binds to enzyme. Enzyme substrate complex is formed. Substrate enzyme is the saccharase and substrate is the saccharose. Number 2, substrate is converted into product. Number 3, product are released, which are the product glucose and fructose. Active site is available for another molecule of substrate. Initial velocity. The reaction rate of an enzymatic reaction is always fastest at the beginning of the reaction when there is the greatest concentration of substrate Y. On y-axis, amount of product formed. On x-axis, time periods of sampling, fixed amount of enzyme and excess of substrate. Initial velocity. Reactant is no longer available for the reaction. Effect of increasing substrate concentration. Initial velocity of the product. Substrate concentration grams per liter. Fixed amount of enzyme but increasing amount of substrate carried out in 11 test tubes. Effect of increasing temperature and reaction rates. Rate of reaction on y-axis. Optimum temperature for two enzymes. Optimal temperature for typical human enzyme. Optimal temperature for enzymes of thermophilic heat tolerant bacteria. Effect of varying pH and enzymatic reaction rate. Rate of reaction on y-axis increases from bottom to top. Optimal pH for two enzymes. pH increases on x-axis from left to right. Optimal pH of pepsin is 2 and optimal pH of trypsin is 8. Effect of competitive inhibitors and enzymatic reaction rates. A substrate can normally bind to the active site of an enzyme. Substrate and active site. Competitive inhibitor. A competitive inhibitor is formed. Effect of non-competitive inhibitors and enzymatic reaction rates. A substrate can normally bind to the active site of an enzyme. A non-competitive inhibitor. Effect of allosteric regulation. Allosteric site, active form and converted into inactive form. Conformational changes in an allosteric enzyme. Activator inhibitor. Active form stabilized by an allosteric activator molecule. Inactive form stabilized by an allosteric inhibitor molecule. Allosteric regulation of the enzyme's activity. Feedback inhibition. Initial substrate, intermediate A, enzyme 2, intermediate B, enzyme 3, intermediate C, enzyme 4, intermediate D, enzyme 5, end product isoleucine is formed. Isoleucine is allosteric site. Active site no longer binds thioline. Cooperativity. Substrate, inactive form of enzyme, active form stabilized by a substrate.